All right, welcome to this Friday night stream. We are working on Gem Wars. We have two sides of this application. The back end is written in ASP.NET 3.1 Core. We have a identity server 4 for authorization server, as well as a web API 3.1. And that's just for downloading the initial scriptable objects that we have passed over to the server. And then we have one TCP server at the moment. We have yet to separate that into a matchmaking and a game server. So we'll just work with this and set up some more of our methods. So if I look at my TCP server, when I'm on the game and I call and I invoke a request over the TCP response. So in our case, we're doing one for a request game, okay? What this is going to do is it's going to deserialize my object into something called a packet request game, which only has a game type. So these are the parameters that we're using to create the game on the server, which is here. And this method is pretty lengthy, and we're going to chop this up a little bit later. But what this does is, oh, it's not this one, it's the data access layer, which is lengthy. So on this onMessage packet, which request game received, we look only at the one parameter of the game type. If it's free play, then there's only one player, so we don't need to worry about that. We're adding the first player here. If it's practice, then we have a computer player, which we've added, and battle is only here as a placeholder. And then here, this is our beefy method, request game. Hold on, let me check the chat. I brought Summer to watch. She's going to be a dev guru like us. Awesome. Welcome, Summer. Welcome to the channel. If you have any questions, please don't hesitate to put them into the chat. Also, make sure you check out our Discord, discord.pixelhorrorstudios.com. And I put all these videos up at youtube.pixelhorrorstudios.com. But you can already see that because the Fallen Hope is on it. Thank you, Pierre. Okay, so this request game, this is what we're going to be working in today. And this is a very large function, which we're going to separate into smaller functions. So currently when I look at this data access layer, I only have my AWS S3 service for, I actually don't need that on this class, just like that. And so we only have a couple of different things. One is the create instance objects. So we have our scriptable objects, which are representative of the templates of anything that's in the game. And then we instantiate an instance of those. Those become an instance object. So this, for example, is for recording data when a user is offline and then they go online later. It stores those instant objects and then sends them to the server as offline. But this request game, this is the meat of the application. So when the game starts, it's going to request a game from the server. It's going to populate all the different components that make up that game and then send it over to Unity. And that's going to be broadcast to each of the clients in the channel or in the game, right? Whoever I go into the queue, it adds me into the queue listing, right? And then when the game is created, we all receive this object, which then pushes us over to the game server. So this object is pretty hefty at the moment. I'm doing this with a transaction because I'm doing many records at one time, and I want to make sure that everything either happens or doesn't. Oh, Summer Salt. That got you, buddy, there. Thank you, Fallen Hope. Welcome, Summer Salt, to the channel. Appreciate it. Tell me about your programming experience, if you could. I've been trying to get Rob to join SL so we can start a business and be billionaires. It's a slow process. I need a little bit of a push. I don't play a lot of games anymore, but definitely I'm easily sold. Okay, so here we're creating our context. In my application database context, in this instance, I'm only using DB context. I'm not using the identity. We have one table in here called player, which is holding my ASP.NET ID. We're also doing this with a transaction so that I can add multiple records, and the whole thing is either going to fail or succeed. And down here at the bottom, you can see that in the try catch, I have a transaction rollback, which returns null. Do it. Oh, amazing at pictures. What kind of pictures? Do you have a sample? I gotta tell you, art's a whole thing. Art's a whole thing. Do you have any samples? Hey there, TTYNS. MR. How are you doing today? Thank you for the channel. or for the channel. Thank you for the follow. I appreciate that very much. Is your screen name based off of those, what is it called, the MSR videos? The ones that help with relaxation, and it's like sounds and people like stroking combs and stuff? I'm just curious. Yes. Throw it up, man. Let me check it out. Okay, so in this, we're creating a game instance, and then we're creating each one of our game players, okay? We're creating our tiers now on our server. We're creating a round on the server. We create the tier colors and gems for that round. We're also creating our match, and our match is typed. So we have a match instance and a match single player instance. And I'll show those in just a moment because there is a fair amount of heredity in these to get these things to be type safe. Down here, we're creating our match players. So if you think about our players or anybody that exists in the system, 8 players join to create one game. Those are called game players. When you're playing in the game, now it's a round. Let's say there's 9 rounds in the game. In each round, you're going to have a number of matches where you play against individual players. So you have round players, and then you also have match players, right? And then here, if you're playing single player, we need special logic to construct your color chance and tier chance and gem chances, right? And so that's what this is for. And so we have a separate instance here of match single player instance, which is a separate instance of match instance, which includes these. And so that way when you're playing single player just against the computer, you have the same feel as though gems and colors are progressing over time as you would be in the 8-player versus player game. Although it's now in single player, so it's only done in one match. So it's as each board progresses in the match, then it will update these tiers and color chances. Thanks, Fallen Hope. Yeah, I gotta put the newest build up there right now. But it still should work. And then any of the requests that people are pushing in for the game, I'm making sure that I'm implementing them right away. There's been a number of bugs that people have pointed out, and they're fixed in the current build. I'm waiting to get the data collection completed before I push the next one, but that should be here in the next 24 hours. Okay. And then this is where I left off, where I'm creating the board. Now, the board needs to say create board draws here. And that's going to be because when you're playing the game, there are 5 different pieces on each board that you can purchase. And it's since you're playing against another individual, they could buy those before you or at the same time. And so that's what these draws are called. And that's not to be confused with another object in the game called drawers. Okay, so draws, something that you can spend the gems that you collect on to purchase. Drawers are your like, when we start the game, I'm going to draw 3 cards, right? Those are my 3 initial pieces. And then when I run out of those 3 initial pieces, I draw 3 more initial pieces, right? Those are called drawers. So we have draws you pay for, drawers you draw. I know that's a little misnomer, but we can always change those titles later. But the reason I do that is because the board has a number of draws and then players have a number of draws. And I wanted to separate them. And when you're playing single player, those draws are illustrated in the drawer at the bottom of the game. And so that's the distinction there. Okay? So after we create our board draws, we also want to do our create player drawers here. Right? That's what I was just saying. So the board has 5 and the player has a number. Why don't we go ahead and show the game where it's at, and then we can jump in and start with our implementation of these changes. Okay, wait for the backend to start. Yes. Have Fallen Hope, I appreciate you letting me bounce a bunch of these graphics off of you for some of the images. We have had a request to change the color of the yellow board pieces, so we will be doing that probably tomorrow. I may do that offline because it's just some Illustrator work. It's fairly straightforward and fairly quick. Okay, so here you can see the game is loading into the server. At the moment it's authing into this TCP server. and we should see it connected, right? If I was to kill the connection, I've implemented reconnecting scripts in here, but no, hello, but no logic in terms of the display on the screen that tells you that this is reconnecting, except for that you can see that this TCP connection will continue to try to reconnect otherwise. So I've just implemented this system because if you're playing battle or if you're in a multiplayer game, you can't switch to single player during that until the game concludes. So that's why we have these mandatory reconnections, if you will. Okay? So let's reconnect the back end here. Wait for this to start. We'll see the... actually, we don't even have to do anything. We'll just see that the client here will reconnect automatically. Boom. And on the client side, connected. So we're good to go. So now, when I start a game, because I'm online, this is going to iterate through this function. So we can look at our context here for our save changes. And we will start a practice versus the AI. Okay, here you can see the save. When I look at this, we're just going to look at my game instance because everything should be in this one object. So a game here has 2 game players, with each one has 1 match player instance. Okay, my player is null because it never populated that because I'm just doing it with IDs at the moment. But there'll be 1 for me and 1 for the nullable computer type. So when we look at the data analytics for this game to see who is playing against who, the computer will have a player ID of good, empty, or just null. And so the game over here is still waiting until this object gets sent back. And what we're going to send back is this very interesting object called the TCP Response Game single player or game multiplayer. So I wanted to show this really fast. If I look at my library under TCP, what I have here is these are my requests and my responses, which are going out to my TCP server, which will be a matchmaking or game server. Okay, I'm only using TCP for this. I don't need UDP with a custom header or anything because it's a gem game. It doesn't need, we're not first-person shooting here, you know what I'm saying? So anyways, I look at the packet. It has a packet type. And then we have this one type called packet DTOs. We'll eventually put this somewhere else. And this is for submitting offline data to the server. So if I look at my request, my packet request game is only going to be requesting a certain type of game, which is free, practice, or battle. Okay? And now, oops, hold on. All right. And now when I look at the responses, I've got this very interesting little bit of heredity in here. So the base class is called TCP Response. And nothing is marked as abstract because I am deserializing each one of these objects and instantiating that class of it, using these enums to then deserialize the next instance until I end up with exactly the type of object that I'm sending from the server or from the client. These objects are recreated in the Unity game as well. So if I look at the response type here, it's either game, round, or match. Okay, let's look at a TCP response game. Okay, so these are very similar to our database objects, except they're very straightforward. These little signs that I have here that say DTO, this stands for data transfer object. So for example, a game instance data transfer object. If you think about a game, it's actually got a number of matches, a number of rounds. We don't have any of those collections in this DTO because a DTO represents the most primitive type of object you can send across the pipe. So it's got a GUID for its ID, it's got a timestamp, it's got a base object type, and that's it. So in my game response, I'm receiving a DTO of the game, 2 DTOs for each one of the players, but if I'm playing in the battle, that'll be 8, okay? are game players, which is the same thing as players, except for that we have different GUIDs to represent that player's instance in the game. And then also the tiers, which are determined for the game. And then we have another nested object called TCP. Silmer and I agree that your goblet is beautiful. Thank you. My wife actually bought this for me for my birthday. And then I love it. I use it all the time. It's my favorite cup. And then my mom came over here to visit, and she asked me, she said, "Why are you drinking out of a vase?" And I went, "Huh?" Thank you, Somersault. Appreciate that. Okay, so this nested round, this round response is nested, right? So if you look at it, this one's got the round DTO, and then the tier color chances and the tier gem chances, and then also a nested match response. And a match response has the match DTO, our match players, our match player boards, because if you think about it, each one of your match players has a number of different boards that they're playing on, so we need those object relationships as well, and the board. But what are the rest of these objects, right? So if I look at a match, I've got match players, match player boards, and board. But this match instance, I have two different kinds of matches. I have single player and I have multiplayer. And so what I've done is I've made another class which inherits from this called TCP Response Match Generic. And this is taking in a generic of type DTO, match instance DTO. And we're using the new keyword here to overwrite the type in TCP response match. If you look, this one in the base class is set to match instance DTO. But in our generic, we're setting it to a type of match instance DTO. Now I'm doing this for two reasons. The first is that when I'm having a collection of these TCP response matches, if I have a generic in there, I can't group them together because it could be a match instance single player or a match instance multiplayer. And now that's not the same type and it won't work. So I need this base class in order to handle my collections, right? But the second reason I'm doing it is that I'm going to end up with typed data for each one of my potential request responses. So in the next iteration, right, because we have this TCP response, and then we've abstracted it a little bit with this generic here. But to simplify things on the logic side, you can look at our TCP response match single player. All right, let's look at the multiplayer one. And this is taking in a TCP response match generic, and its type is match instance DTO, which means that this type, when we work with this type individual class, will match instance DTO exactly. But that is different from a single player, because a TCP response match single player has these two other fields on it, the tier color chances and the tier gem chances. The reason why this is incorrect, and we'll remove these, is because this is DTO, so we're not supposed to have any relationships inside of it. So we'll get rid of those two, right? So these are our tier color chances and tier gem chances that are available for single player. And again, that's because that one match is all you get. You don't have multiple rounds. But for multiplayer, you can see that we have this match instance DTO. Okay, seems like a lot of work. Let's move on. TCP round response round. Same thing. We have a round DTO. We have the color chances and the gem chances. Remember that the default for the game is that color chances and gem chances are per round, but only when you play single player is it per match. So we're capturing that. And then additionally, inside of TCP response round, we have this match response, which is TCP match. Okay. And same as before, we have a generic. And the generic this time now has three types in it, right? The first one is the match instance DTO, which can be match single player or just match instance. The second one is a type of response for that match, which is passing in the match instance DTO. And the third is the type of round. And I'm setting this up so that if I need to change out these objects and switch them with, like if I need round multiplayer instance, then I can change that out later. And then the same thing as before with using the new keyword. I am overriding the type in the base class. And so if I'm working with something that's an instance of round generic, it will be type safe. And we're going to do the same thing again for single player. And this TCP response round single player is the simplified final object that we've created. And the reason we're doing all this is because we are serializing these objects into JSON, sending them across the pipe, and deserializing them on the server, or vice versa. So we need to be able to do that with the enumerators that are in there. And then we also need to make sure that each one of our objects are type safe, because we're using typed language C#, where we don't necessarily want to be passing around dynamic objects. So in this single player response, you can see I'm specifying the types here. So if you remember the parameters that we just passed in, we had a single player instance DTO, a match response single player, and then this round. And round is the same for everybody, right? And if you look at the multiplayer one, same thing. We have a round generic. We're passing in the match, the response for the match multiplayer, and then the round. So between TCP response round multiplayer and single player, these are type safe. And we can have a collection of type TCP response and then input these in there and then use polymorphism and reflection to determine what type they are. The final one at the top is called TCP Response Game. And it's going to be very similar. It's got the DTO for the game, the DTOs for the players in the game players, which are the specific instances of those players for this game. So it's many to many, or one to many. And then the tiers, which are auto-generated here on the server and then passed over to the client. And again, we're going to be passing in TCP response round, which is not typed, because again, it could be multiplayer or single player. So that's where our generic comes in. And the same thing now, instead of having 3 generics, now we have 5. So we've got the first one is the match instance DTO. The second one is the response of the match. The third one is the round instance, which again, we only have 1. The fourth is the round response generic, which we only have 1, but we're setting it up in case we want to have more. And then finally is our game instance DTO. And again, same thing here. We're overriding the properties with their correct type safe versions. Now, this would be a nightmare to work with in code. And so again, I've done the same thing where I've created a TCP response game single player. And you can see each one of these types is here for single player. And the same thing for multiplayer. Everything is type safe. And the reason for this heredity comes into the TCP server. So if I look here, I'm serializing this response object from my data access layer. And let's look at what that is. My response object is just the generic that we started with, right? TCP response game. There we go, just fixing the volumes a little bit, right? And then when I look down here at the bottom of it, if my match is single player, then I'm going to return this typed single player object. And all of these things are typed. So round response is a round single player. Match response is a match single player. And the same thing for the multiplayer. So here we have a round multiplayer and match multiplayer. Now the importance of this comes in right here. So in the single player response, our main difference is that 3 layers down, we have a single player match, which includes tiers, color types, and tier gem types, right? But in multiplayer, we don't. And so because of this structure, we have type safe objects being returned here and here. that are going to go through polymorphism for TCP Response Game. And then they're going to be serialized by Newtonsoft here, and then sent over to the server. Sent over to the client. Sent over to the client, right? Okay. So on the client side, we have a new TCP class in here. Well, I guess we wrote this together. We have two. The first one's called TCP connection. We don't need to worry about this. This is how it's connecting to the server. TCP manager, though, when I look, so now we're going to be sending one of those type safe objects across the pipe, and we need to deserialize it appropriately. So when I'm looking at my message event, if it's an incoming message, I'm going to go through this deserialization daisy chain, if you will, where I start at the most basic, and then based on the enumerators that are in them, I'll continue to deserialize that object until we have ended up with our type safe object. So a response here is only being done because response includes data. And data comes from tcp.net, which is the library I wrote and is up on NuGet that we're using for this project. And then this one, we're using the data from response. So this is just a one string, and we're deserializing that into a TCP response, which includes this one response type, which in our case, we know we have game, round, and match. So if it is a game type, we're going to deserialize it again into a TCP response game. Perfect. And this is going to deserialize things into this generic object, not generic, pardon me, this base object. So it's not going to have all the properties. So the next thing we're going to do is we're going to switch on our game type, which is returned here. And from that, we're going to deserialize it one more time into the type safe version. And we have the same structures in our Unity app that we did in our C# app. So at this point, we've deserialized down the chain, and we know our specific type, and now I can deserialize into that and fire the event. And that's how the TCP structures are set up. So now we have interconnection between the objects, but then we can serialize and deserialize them to type-specific options that have parameters that we're interested in. Novice Styles, 8-ball. Unfortunately, the 8-ball is not working. I need to get the bots up back and running. If you ask nice, though, Fallen Hope may just be the 8-ball. Or you could help out and make a bot if you like. My server bills, they're about $130 to $140 a month at the moment. Oh, God. The reason it's so high is that I'm using Amazon Web Services, and I have one EC2 instance that I commission. It's a large size. It's running Linux and EC2, which is Elastic Container Service, so Docker. And on that Docker container, I have 44 running instances on it. And that's why that price is so high. So I think there's like $35 or $40 for the relational database services, and then about $100 for the EC2 instance. And then that's got 45 containers on it. Yeah. So at some point, because everything is set up to be a distributed system, I'm very excited to separate that into smaller servers, right? Some of the hosting I do for things that are not in production. I host out of the FreeNAS in the closet. I have another server in the closet there, and a domain, subdomain here at the house that then uses Amazon Web Services as a reverse proxy for hosting. But for anything on production, it's all out there. And so what I really like to do is start to separate that by app and to commission smaller servers instead of loading it all onto one But in the meantime, that's where we're at. And maybe one of these days we'll look at Kubernetes and maybe we'll figure that out here on stream. Because Kubernetes should be able to manage my horizontal scaling without me doing anything other than setting it up. And in that case, then I could have individual servers for each one of the apps. They may have 4 to 8 containers, right? Because you have an identity server, the web app, the web API. That's for the most basic of them. Then there's usually like TCP services, WebSocket services. There's a static website typically, because if we're using Angular for the front end, then we need something that SEO is going to be able to eat up. I'm already up to 5 instances. So that goes onto one machine, right? And then if I have a cluster of those, then I can easily scale those vertically or horizontally if I need to. But at the moment, everything is on one. That's not bad. Have you ever looked at Google Cloud Run? No, I have not heard of Google Cloud Run. Is that Google's AWS equivalent? Like Azure, Well, I thought Google owned... No, that's not right. So what? There's Amazon Web Services, there's Azure by Microsoft, and then there's Google Cloud Run by Google. So heads up, K8S will eat up your bill off. Make it like 500 minutes. What is K8S? I've never heard of that. Cloud Run is Kubernetes native. Okay, that's perfect. Okay, that makes sense. It's pay-as-you-go container service system. Okay, so Amazon Web Services is the same thing. It's called Elastic Beanstalk. The thing about that is that if I launched EBS per application, the costs are astronomical compared to if I manage it and then commission one server and dump them all onto that, or commission a couple of servers. Because anytime you have anything that's fully managed, then you have to pay for that management. Yeah. K8S is Kubernetes. I have never heard it described that way. I appreciate you telling me that. So, okay, so that sounds, it's different than Beanstalk. So it sounds like it's like Lambda is what you're saying, then you pay per request. So AWS has Lambda where you make a function out there and then you post it up on Lambda, and then every time you make a request out to it, that's where you incur your bill. And that's what I think, Lambda's doing too, is running Kubernetes fully managed, but it's behind the scenes, so I don't know that. But they're managing all that, right? Okay, that was a fun little aside. Okay, so that's the way our serialization is working at the moment. So what we're going to do is we're going to be continuing on the serialization practices. If I look here at my mono behavior under base game manager, when I start the scene, you can see this muddled logic that I've implemented where I'm separating things into is online and is not online. And that's not great. But what we're going to do right here is we're going to create the moves for the draw. So why don't we go ahead and get started.